Have you ever wondered how mathematicians solve travel problems? Well, they often use the concepts of walks, trails, paths, cycles, and circuits. These terms are part of graph theory, a fascinating branch of mathematics. Think of a walk in a graph as a sequence of vertices and edges, kind of like hopping from one point to another. Now, if you take this walk without repeating any edges, that's what we call a trail. Next up, we have paths. A path is a walk where you don't repeat any vertices or edges. It's like taking a stroll without passing the same point or route twice. A cycle, on the other hand, is a closed trail where you start and finish at the same vertex, like going around a loop. And lastly, a circuit is a closed trail where you don't repeat any vertices except for the starting and ending points. Now that we've defined our terms, let's see them in action with a few examples. Consider a walk from point A to point B. In the language of graph theory, a walk is a sequence of vertices, or points, and edges, or paths, that connects these points. Imagine meandering through a city. You could visit the same location or take the same route more than once. That's a walk. Now, let's think about a trail. A trail is like a walk, but with a twist. You still move through a sequence of points and paths, but in a trail, you don't repeat any paths. Like taking a scenic drive without retracing your steps. Every road is a new experience. So what's the key difference? A walk allows for repetition of locations and paths, while a trail insists on unique paths. It's like an adventurous hike compared to a leisurely stroll around the same park. As you can see, walks and trails offer different ways to navigate a graph. Now imagine you're at a point and you want to return to it without retracing your steps. Let's dive into the world of paths, cycles, and circuits. These are all fascinating concepts that can help us navigate through a graph, and they each have unique characteristics. To start with, let's talk about paths. A path is a trail where no vertices repeat. It's like walking through a garden and making sure you don't visit the same flower twice. You're creating a unique trail, ensuring every step you take leads you to a new place. This is what we call a path in the field of mathematics. Moving on, let's discuss cycles. A cycle is a closed trail that starts and ends at the same point. It's like taking a tour around a city, starting at your hotel, visiting various attractions, and then returning to your hotel at the end of the day. The important thing is that your start and end points are the same, forming a closed loop. This is what mathematicians refer to as a cycle. Finally, we have circuits. A circuit is also a closed trail, much like a cycle. However, in a circuit, the vertices do not repeat. It's like taking a circular hiking trail, where you start and end at the same point, but you don't cross the same spot twice. You take a unique route, making sure each step is fresh and new. That's a circuit for you. Now, why are these concepts important, you might ask? Well, paths, cycles, and circuits are fundamental concepts in graph theory, a branch of mathematics that studies the properties of graphs. These concepts provide us with various ways to travel within a graph, helping us to understand and visualize complex networks and connections. Paths, cycles, and circuits add depth to our understanding of graphs, enabling us to explore and navigate them in different ways. Whether you're trying to solve a mathematical problem or just understand the world around you, these concepts can provide valuable insight. Paths, cycles, and circuits provide even more options for travel in a graph. We've covered a lot of ground today, so let's take a moment to recap. We started with the basics, defining the concepts of walks, trails, paths, cycles, and circuits. We learned that a walk is a sequence of vertices and edges, while a trail is a walk with no repeating edges. We moved on to paths, which are trails with no repeating vertices, and cycles that close on themselves, forming a loop. And we wrapped up with circuits, which are cycles without any repeated edges except the starting and ending vertex. These concepts are not just mere mathematical jargon. They are instrumental in solving problems related to travel. Whether it's planning a city's public transit or organizing a world tour, these principles help us figure out the most efficient routes and schedules. Remember, whether you're walking, trailing, or cycling through a graph, the journey is just as important as the destination. Keep exploring.